In this video, we continue with finding the limit of trigonometric functions. So this is the second case of finding the limit of trigonometric functions. If you didn't watch the first case, you can click on this card which will appear here to watch it, because it is important to watch the first case, because there we explained some important properties, rules about sine, cosine, tangent. We saw some examples also for you to better understand the second case, and we will have also a third case to understand them better. Okay, so if you encounter the following case, when x approaches to plus or minus a, or x approaches to plus or minus p over 2 or p or and so on, so you must solve by using the method of assumption, or it is possible to see some call it substitution method. Okay, let's see first example. Find the limit as x approaches to p over 2 for cosine of x over x minus p over 2. So we substitute each x by p over 2, so cosine of p over 2 over p over 2 minus p over 2. So cosine of p over 2, so we'll use this table to find out what is cosine of p over 2. So this is x can be 0, can be p over 6, and so on. Here is cosine x, sine x, tangent x. So when we say cosine of 0 is 1, okay? So if I ask you what is cosine of 0, you will say it is equal to 1. What is cosine of p over 6? It is equal to, in this table, it is the square root of 3 over 2. Okay? And so on. In our case, we have cosine of p over 2, so we are here, and it is 0. Okay? So it is equal to 0, then p over 2 minus p over 2, it is equal to 0. This is indeterminate quantity, and we have to avoid it, right? So what we will do is, we'll use the assumption method, or some people call it a substitution method also. So we assume that u is equal to x minus p over 2. So u, it is from your choice. You choose a variable, okay? If you want, you can call it v or y as you wish. Then you will deal with the denominator. So the denominator in general, it is of this shape, x minus something or plus something, okay? So x minus p over 2, okay? So u is equal to x minus p over 2 from here. Then you will take minus p over 2 to the other side. So you'll get p over 2 plus u is equal to x. Then when x approaches to p over 2, so we have it from here, x approaches to p over 2, this leads u approach to 0. Why? Because we already said u from our assumption, okay? We assume that u is equal to x minus p over 2. So u is equal to x minus p over 2, right? So u is equal to, we substitute x by p over 2 from here. We have x approach to p over 2. So p over 2 minus p over 2, this is equal to 0. So we are in the context of limits, we say u approaches to 0, okay? Then we rewrite our equation. What we'll do is, we'll say find the limit as u in this case. So you see, before we had x, in this case we substitute each x by u, okay? Or you will see. So u approach to 0 for cosine of, so x, what is x here? X here is this one here. So x is equal to this one, okay? So this part is equal to this part, and this part is equal to this part. So we substitute x here by p over 2 plus u. so p over 2 plus u. Then we have x minus p over 2, so we had already x minus p over 2. So this is equal to u, right? Or u is equal to x minus p over 2. So we substitute this one by u, okay? So we simplified the expression in this case also. Then what we will do is we have this table. You should use it in general while dealing with this type of equations. So this table is when you have, in this our case, you have we have it from here. So we have to follow this cosine of p over 2 plus u. So cosine p over 2 plus u is, we are in this case here. We have a plus b. So here is a, here plus b, okay? So we take cosine a of the angle a, cosine b minus sine a, sine b. So cosine p over 2, this is a, multiplied by cosine u, this is b, okay? We follow this one, a, b, okay? This is a, this is b, okay? So this is a, this is b, okay? Minus sine p over 2 is a, okay? Multiplied by sine u, it is sine here, sine b, it is u here, okay? That's why we take u. So cosine p over 2, we already saw that it is 0, right? 0 multiplied by cosine of u minus 1. Why? Because sine of p over 2, sine is here, sine p over 2, it is 1. We already have from the equation minus, so minus 1 multiplied by sine u. So this expression, this will become 0, this one here, because it is multiplied by 0. And minus 1 multiplied by sine of u, it is minus sine u. That's why we get this one here, okay? And u, we don't touch it, we put it here, okay? Finally, we find the limit. So find the limit as u approach to 0 for minus sine u over u. This is equal to minus 1, okay? We already saw the formulas for this. When you find the limit of this type of equation, you can click on this card here. We did it in the first part of finding the limit of trigonometric function. That's why I said it is important to watch it if you didn't watch it, okay? Let's see second example. So find the limit as x approaches to 1 for sine p of x over 1 minus x. So if you calculate the limit as x approaches to 1, you will get 0 over 0. So this is indeterminate quantity, right? And we have to avoid it. So what we will do is, we will assume that, so keep in mind, you always assume a variable, you name it as you wish. In here I name it u, is equal to the denominator, 1 minus x, okay? Then we will take x to this side and u to the other side. So you will get x, so from minus x, it will become positive x plus x. So x is equal to 1 minus u, okay? U becomes negative because we take it to the other side. Then when x approaches to 1, from here we have x approach to 1. This leads u approach to 0. Why? Because from our assumption, we assume that u is equal to 1 minus x. So this is equal to x approach to 1, so we substitute x by 1. This is equal to 0, right? 1 minus 1 is 0. And in the context of limits, we will say u approach to 0, okay? So from here we rewrite our equation. We say, we'll find the limit as u in this case. So we change x x here, and x here by u. So limit u approach to 0 for sine p, we didn't touch it. So x we substituted by, what is x here? X is equal to 1 minus u. So this part is equal to x, and x is equal to this part, okay? So we write 1 minus u over 1 minus x is, we already assumed that u is equal to 1 minus x, so it's substituted by u. And then we multiply p by 1 and p also again by minus u, we get sine p minus pu over u, okay? Then we are in this case, we use this table again. So we have to work on this sine p minus pu over u. So we work here, we are here now. We take this sine p minus pu, okay? And we try to simplify this expression using those formulas, those identities. So we look, where is sine a minus b? So here is a minus b. So we are here in this case, right? So you take sine a, so here is a, here is b. So sine p, okay? Multiplied by cosine b. So multiplied by cosine, here it is pu, okay? Minus cosine a, cosine p, sine b is sine pu, okay? So sine p here, so we are here, sine p is 0, right? So we substitute it by 0, multiplied by cosine pu, we don't touch it, minus we have it from here, from the rule, and cosine of p is minus 1. So we put minus 1 multiplied by sine of pu, we didn't touch this one. So 0 multiplied by cosine pu, this will become 0. Both of them are 0. And minus multiplied by minus 1 is 1. And 1 multiplied by sine, so sine pu. So finally we have sine pu, okay? Now we find the limit. So we have sine. Find the limit as u approach to 0 for sine pu over u. So this is equal to p. So the limit as u approach to 0 is equal to p, okay? So in this way we found the limit, okay? Thank you for watching, and hope to see you in the next video.